In the high-stakes realm of advanced military aviation, few competitions have carried the weight, intensity, and strategic implications of the ongoing face-off between Boeing and Lockheed Martin over the F-47 NGAD next-generation air dominance fighter program. Born from the need to dominate contested airspace well into the mid-21st century, the NGAD initiative represents more than just another jet. It is the future of air superiority, autonomy, and aerospace innovation. With global power rivalries escalating and the threat environment growing ever more complex, the United States Air Force has placed immense pressure on the nation's top aerospace contractors to deliver a platform that will maintain its dominance in air combat for decades to come. Boeing, with its deep legacy in military aviation, is bringing a bold and ambitious vision to the NGAD project. Having previously suffered setbacks with programs like the KC-46 tanker and other modern acquisitions, the company has taken an aggressive posture in this bid, investing heavily in modular design concepts, advanced stealth integration, and AI-enabled combat systems. Boeing's NGAD concept, allegedly nicknamed the Phantom Blade, in internal circles, emphasizes interoperability with unmanned systems, sensor fusion, and survivability in denied environments. Boeing engineers have worked closely with DARPA and AFRL Air Force Research Laboratory to test out next-gen propulsion systems, adaptive engines, and low-observable materials that push far beyond what was achieved with the F-22 or F-35. Lockheed Martin, however, enters the arena as the reigning champion of fifth-generation fighters. As the architect of the F-22 Raptor and F-35 Lightning II, Lockheed has the advantage of recent experience and infrastructure tailored to stealth aircraft production, sustainment, and systems integration. Their NGAD proposal, rumored under the project code name Black Halo, leans heavily on evolutionary improvements built atop existing platforms, but with radical advances in artificial intelligence, loyal wingman coordination, and seamless command integration. Lockheed's offering is said to push boundaries in autonomy, allowing for manned-unmanned teaming where the pilot becomes more of a battle manager than a traditional dogfighter. The battle between the two defense giants isn't merely technical, it's political, financial, and operational. Each has cultivated key relationships across the Department of Defense and Congress, each lobbying behind closed doors to gain favor in a selection process shrouded in classified briefings and tightly controlled disclosures. Billions are at stake, but more importantly, so is the strategic posture of the United States in any future peer conflict. China's J-20 and the rapidly maturing Russian Su-57 and Su-75 platforms have catalyzed an urgent American response, one that the NGAD is expected to answer with unmatched speed, stealth, and lethality. Among the central questions surrounding the NGAD program is whether the Air Force will choose a single vendor or a distributed ecosystem. Some suggest that Boeing and Lockheed may each play a role, one focusing on the manned platform, the other on autonomous support drones. However, both companies are currently presenting their designs as turnkey solutions, each convinced that their technological edge will secure them the full contract. Boeing's aircraft is believed to emphasize modularity, allowing for rapid upgrades and role swapping between air dominance, ISR intelligence, surveillance, reconnaissance, and electronic warfare. Lockheed's is more mission-integrated, with systems baked into the frame and AI that learns over time from operational inputs. Boeing is championing open architecture and plug-and-play compatibility with emerging technologies. Lockheed is focusing on field-tested reliability and deep sensor integration across the Joint All-Domain Command and Control (JADC2) ecosystem. Testing and prototyping are already underway in the classified sectors of Area 51 and other undisclosed airfields, with flight data and simulations being pored over by Pentagon analysts. Both aircraft are being tested against future threat scenarios, hypersonic intercepts, swarm drone attacks, and coordinated satellite jamming. The F-47 NGAD isn't just being designed to fight today's wars better, it's being forged to win the wars no one has yet imagined. Insiders say that the final decision could come down not just to capability, but to cost, scalability, and risk. Boeing is offering aggressive timelines and low procurement costs, while Lockheed touts logistical synergy with existing F-35 infrastructure. But the Air Force may ultimately lean toward the design that offers greater survivability, lower maintenance requirements, and adaptability for decades to come. Regardless of the outcome, one thing is certain: this battle between Boeing and Lockheed will reshape the American air combat doctrine for the next 50 years. It is not simply a matter of which plane flies faster or stealthier, but which company understands the future of warfare better, and can deliver it now. The F-47 NGAD will not be a continuation of the past. It is a leap forward into a world where dominance is defined by data, automation, and the ability to outthink an adversary before a missile is ever fired. The F-47 NGAD fighter program is more than an aircraft. It's the technological pivot point for future air combat, requiring not only superior speed and stealth, but also AI integration, manned-unmanned coordination, and digital warfare capabilities. Unlike traditional fighters that focused on raw power, maneuverability, or singular stealth applications, the NGAD platform is being developed as a multi-domain command and control hub in the sky, with the F-47 envisioned as the centerpiece of a vast, interconnected combat ecosystem. This includes operating in lockstep with swarms of autonomous drones, referred to as collaborative combat aircraft (CCAs), each tasked with unique functions such as electronic jamming, missile interception, surveillance, or strike missions. The human pilot aboard the F-47 won't be simply flying a jet but will instead operate more like a mission commander, overseeing and directing the behavior of a networked array of AI-controlled wingmen, each capable of dynamic decision-making and reacting to real-time threats without constant human input. This paradigm shift demands unprecedented levels of machine learning, onboard processing power, and secure data fusion across domains. The F-47 is expected to leverage quantum-resistant communications, edge computing, and real-time threat analytics while maintaining absolute electromagnetic stealth. It must be able to ingest information from satellites, ground units, maritime forces, and cyber intelligence nodes, process that data instantaneously, and use it to make tactical decisions faster than any adversary. Superior speed and agility alone are no longer sufficient to ensure dominance. The aircraft must be a flying brain as much as a flying weapon, capable of disrupting enemy networks, protecting itself from cyber infiltration, and launching preemptive attacks based on predictive threat modeling and AI-driven threat identification. Unlike previous generation fighters that were designed primarily for air superiority or strike missions, the F-47 NGAD is being built with plug-and-play modularity in mind. Its internal architecture will allow for rapid software upgrades and hardware swaps, making it a continuously evolving platform instead of a static, decade-locked system. Sensor suites and mission systems are expected to be open architecture compliant, allowing the military to integrate third-party technologies at will and rapidly respond to new threats or mission demands without relying solely on the original manufacturer. The airframe itself may utilize shape-morphing aerodynamic surfaces, electromagnetic skin technologies, and smart materials that can heal or adapt to damage mid-flight, all while minimizing its radar, infrared, and visual signatures. The NGAD program also marks a turning point in how the United States approaches deterrence and survivability in high-threat environments. In a future conflict, particularly with peer or near-peer adversaries like China or Russia, traditional methods of air domination, radar tracking, beyond visual range missile locks, and AWACS-guided engagements will be at risk of rapid neutralization by electronic warfare or satellite denial. The F-47 must not only function without GPS or satellite communications but must also thrive in such degraded environments. It is expected to host onboard autonomy modules that allow it to continue fighting, navigating, and communicating locally even in the event of complete battlefield isolation. Its sensors will use artificial intelligence to parse false signals from real ones, distinguish decoys from true threats, and prioritize targets in fluid, fast-paced engagements. Further compounding the complexity of the F-47's role is its expected involvement in long-range penetration missions. With China deploying A2AD anti-access area denial bubbles that extend deep into the Pacific, the United States needs a fighter that can evade, survive, and strike within these zones without relying on vulnerable forward bases or refueling tankers. To that end, the F-47 is anticipated to feature revolutionary propulsion systems, possibly variable cycle engines or even hybrid electric turbine arrangements, that allow it to operate at multiple speed regimes and altitudes with unprecedented fuel efficiency. Supercruise capabilities will be a given, but so too will be the ability to operate silently and slowly when needed to loiter undetected for ISR roles. The digital backbone of the F-47 will also play a central role in enabling adaptive mission planning and real-time battlefield orchestration. Pilots and ground crews will be supported by predictive AI assistants that can simulate thousands of mission permutations before a sortie is even launched. Maintenance will be managed not by static schedules but through real-time condition-based monitoring using embedded diagnostic sensors, reducing downtime and increasing sortie rates in sustained campaigns. The aircraft will even interface with cyber warfare assets, acting as a node for offensive and defensive cyber operations in contested airspace. In the realm of survivability and defense, the F-47 will introduce a new class of active countermeasures, including directed energy systems such as lasers or microwave emitters capable of disabling incoming missiles or enemy drones. Defensive autonomy modules may allow the aircraft to autonomously conduct evasive maneuvers, deploy decoys, or even spoof enemy sensors while the pilot focuses on offensive strategy. The cockpit itself may no longer be physical in the traditional sense, with next-gen augmented reality or helmet-mounted display systems offering a complete 360-degree battlespace view, integrated seamlessly with drone camera feeds, satellite imagery, and live threat overlays. Boeing and Lockheed Martin represent two distinct philosophies for future dominance, Boeing pushing for modular, open architecture innovation, while Lockheed leverages proven platforms and deep integration with existing systems. The outcome will shape U.S. airpower for generations. Boeing's approach reflects a bold departure from legacy systems, emphasizing flexibility, interoperability, and rapid evolution through a software-defined architecture. Its vision is grounded in the belief that future threats will emerge too quickly for monolithic design cycles to remain effective. As such, Boeing's NGAD concept is built around a modular core, a combat aircraft that can be reconfigured for vastly different missions by swapping out key systems, sensors, and even structural modules with minimal downtime. This modularity extends to both software and hardware, allowing for rapid integration of third-party systems, experimental subsystems, or theater-specific customizations without needing to reinvent the airframe or undergo years of requalification. The heart of Boeing's philosophy is openness, not just in terms of technology but in development culture. They are advocating for a digital engineering pipeline that allows the U.S. Air Force and its partners to continuously test, update, and refine aircraft performance in a virtual environment before changes ever touch physical hardware. The idea is to drastically shorten innovation cycles while reducing cost and risk. Boeing envisions a battlefield where its NGAD platform communicates not only with other jets, but with ground systems, satellites, and naval assets in a seamless, unified combat cloud, with all systems feeding into and drawing from a single real-time data stream. Their design philosophy treats the aircraft as a node in a larger AI-driven network of platforms, making the F-47 not just a fighter, but a battlefield coordinator, intelligence gatherer, and adaptive strike leader. Lockheed Martin, by contrast, is doubling down on its legacy of integrated air dominance through tight coupling of software and hardware in a system that prioritizes battlefield-tested performance and sustained lethality. Building on its success with the F-22 and F-35, Lockheed's approach is based on vertical integration, ensuring that every component of the aircraft, from radar to weapons management to stealth coding, is developed in-house or with long-standing trusted partners. The benefit of this method is continuity, reliability, and deep optimization, where every piece of the system is tuned to work in perfect harmony with the others. Lockheed's NGAD concept draws from decades of operating within classified environments and focuses heavily on survivability in pure contested airspace, advanced stealth that evolves from the Raptor's legacy, and mission systems that align directly with existing command and control infrastructure used across NATO and U.S. forces. Rather than emphasizing modularity, Lockheed's strategy leans into deep system fusion, where sensor inputs, threat data, and targeting solutions are processed through a centralized combat brain capable of making high-confidence decisions in milliseconds. This system would not rely on plug-and-play upgrades but would instead evolve in carefully structured blocks, each rigorously tested and deployed across the fleet to maintain consistency. Lockheed also places strong emphasis on mission assurance and global supportability, with logistics, training, and maintenance modeled closely on its existing F-35 ecosystem, enabling faster operational integration and reduced learning curves for pilots and crews. Boeing's design reflects a mindset prepared for fluid, unpredictable future conflicts, where open standards, adaptability, and rapid system swapping may provide the agility needed to counter a rapidly evolving threat landscape. Lockheed's design reflects a belief in a hardened, tightly integrated platform, one that maximizes the synergy of its parts and builds on proven strategic advantages with evolutionary leaps in technology. Boeing is betting on a decentralized, interconnected future of combat, where the aircraft must evolve constantly alongside the battlefield. Lockheed is betting on the perfection of a unified warfighting machine, deeply meshed with existing defense networks and capable of overwhelming adversaries with superior coordination, stealth, and firepower.